So, how do you calculate the pH of hydrochloric acid? So this will officially be or 80% done, but oh yeah, I recognize this. I almost blanked out for a second. pH of hydrochloric acid, HCl. So I believe if you saw my last session, I did explain this, but I'll explain it again. To find out how to calculate pH, you have to first understand whether you're dealing with a strong or a weak acid. And how do we know if it's strong or weak? We need to know the Ka, the dissociation constant for that acid, okay? And if it's greater than 1, that's a strong acid. And if it's less than 1, but it will never be less than 0 because there's no, it needs to dissociate. You can never put something in and it forms more of that thing and there's nothing in the solution present of it initially. So this would be the weak acid border, okay? So now knowing that, let's move over to our acids or bases sheet. Hydrochloric acid is sitting all the way over here. It doesn't even bother saying what the Ka value is. It just says that because it keeps increasing here, right? And if 1 is here, that means everything above hydronium ions, H3O, is going to be greater than 1. So, with that being said, okay, hydrochloric acid is a strong acid. Now you're probably wondering, so for Gerald, why does that matter when it comes to figuring out the pH? It matters because when you write the formula down, right, it dissociates completely. Plus H2O. Okay, there's no backwards arrow. This is just going to form Cl minus plus H3O plus. Okay, and because it dissociates completely, there's going to be a 1-to-1 ratio. For every 1 mole of HCl, there's 1 mole of Cl minus, and more importantly, 1 mole of H3O plus. What does that mean? Because the formula to find out the pH is negative log of the concentration, so moles per liter. So it's like this can actually even be substituted with, like, for every 1 molarity of it, moles per liter, it'd be the 1 molarity as well for each one. And exactly, it's a negative log of H3O plus concentration, which is, as we've established, is just a 1-to-1 relationship. So what does that mean? It means that if we had 0.34 moles per liter of hydrochloric acid, we would also have 0.34 moles of H3O. Okay, meaning that you can literally just plug in this number into that equation over there, negative log of 0.34, okay, and you get a pH, okay, of 0.47, just to be able to round, okay. And you see that's actually a very low pH, which is fitting for this strong acid. It's just 1-to-1 ratio, all the parts of it dissociated, hence how we got this pH right here. Okay, so yeah, let's see how we did. Exactly. We had that important formula, which is what we need. pH equals negative log H3O. We have the right equation of how it dissociates. And for this one, they used 0.20, and exactly just plugged it in, and it will form that answer they got. If I plugged in 0.20, I get 0.698, which just rounds up to 0.70. That is the way you calculate the pH of a strong acid like hydrochloric acid. If the question was asking for how to calculate a pH of a weak acid, that is a whole different